Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Very long time not posting any video. Okay, so for today I would like to share about the we call it simplest way or we call it preliminary how I analyze any chemical compounds or component in the extract, whether it's plant, animal, or sometimes the extract came from bacteria, for example. So usually for me, I'm very not very quite used to GCMS brand of Agilent. So usually when you purchase an instrument of GCMS, gas chromatography-mass spectrometer, it will come together with the software. We call it enhanced data analysis. Okay, but unfortunately in this video, I'm not going to share about how to install the software. Actually, the software can be installed at your PC, all right? And then you can run the samples in the instrumentation and then open the data, the raw data via your PC. So, for example, if I have analyzed the sample, I need to open up the file, okay? Click file and then load data file. So go to the folder that you keep your data. For example, I have the sample number 2, okay? So we name it as A12-1. One is the first replicate, for example. So I can make it bigger. So this is the chromatogram that we are able to establish. Okay. Usually, if you want to know if we can zoom to each of the peak, yeah. So usually one peak is denoted as one compound. So to know about this peak, what is the possible compound that being detected? So you need to integrate first. Okay. So in this case, I will go to chromatogram and I will click select integrator. Okay. In this enhanced data analysis on the GCMS Agilent brand, they have two integrator. So if you run your sample without standards, chemical standard to compare, so we will choose chem station integrator. Okay. In the case of you have your own standard, for example, I'm quite used to analyze fatty acids and then I have the fatty acid standard. So if I want to use the library, I will use the RTE integrator. Okay. So as far I'm concerned, as far as I know that RT mean retention time. If I'm wrong, excuse myself. Okay. So in this case, since I don't run my sample using any kind of standards, chemical standards. So I just choose chem station integrator. So usually in this, when you purchase this UCMS, it will come together with the software and then with the library. Okay. So when you click this one, so we already choose the integrator. Okay. So and then we go to chromatogram again, then we click integrate. Okay. So when you integrate your chromatogram, you will get this blue colored number. So actually this blue colored number means the time, okay, in minutes, when the this particular of peak eluted. For example, at 8.745, this one particular peak eluted. So for example, we have 1, 2, 3, 4, 5 peak. Okay, so but we don't know yet what is the potential chemical compound detected in this chromatogram in the sample. Okay, so when you integrate your compound, your peak, that they will inform you that the system already acknowledge this peak in the software itself, and then meaning that they have introduced or registered at this particular retention time. And then for each of these peak, actually you can double click or right click here, and then you will get another window here. We call it mass spectra. So from here, those blue colored at the bottom is the mass of the compounds. And then from here, you can every time the voltage we call it emitted, emitted hitting the compound in the GCMS, So the compound will be broken down and then into fragments. So that's why those fragments will be collected here. So usually if you see, for example, 188.1 and 174.1, you can actually deduce or sometimes to predict from 188.1 um, mass per Z, and then we have 174.1 mass per Z. So what are the potential chemical component, is not component, element that being removed from this 188.1? Okay, but for today we are not going to discuss about this one. What we are looking for is how to use the library to try to identify the potential compounds detected in this sample. Okay, so I just go back to the chromatogram, okay, and then unzoom it, okay, and from here I can find the select the library. So go to spectrum and then select the library. Okay, unfortunately this is a very old software, so when we purchase the software, the library that we have at is the 2011 version. So there's not many compounds detected compared to the latest library database. So the one that we have is 2011. Okay. However, for this video, we just want to show you how to analyze the result from the GCMS. So let it go and let's go to find the potential compound. So you just click OK, and then you go back to Spectrum. This time you can click Library Search Report. Okay, and then you can click Screen. So you can see at the bottom part here, the system is matching, try to match those mass spectra for individual compound here against the library that we have. Okay, so usually it will open a WordPad. So if you want to know what are the potential compounds, we just reduce the number of the size of the font. Okay, so from here you can try to identify the compound. Okay, however, sometimes very hard to identify. Usually what we will look at the last column here. You can see at the top, qual. Qual means the quality of the compound detected matching against the library. So in this case, for example, at 10.779 minutes, the retention time, and the blue color in the chromatogram here, at 10 point, we go back, 10.779. This one, it's more or equivalent to 10.775. So what are the potential compounds that being detected? So from here you can see we get trimethyl phosphate silanol, okay, 3,1-silanol. So the quality of this compound, this peak, yeah, this one is big, okay, against the library at 99%. So it's very accurate for this particular retention of time. And then you can see others as well. Okay, you can see we have 1%, meaning that there is no match against the library. However, in the next video, later on, I will try to show to you how to actually analyze the actual sample by we call it deducting the background from the software itself. Okay, even though here, yeah, we get tris hydroxymethyl aminomethane, yeah, and then the match is 91%. Okay, so usually, if in this case of myself, when I want to analyze or to report, I will choose any compound that having a quality number 80 and above. Okay, which you just try to simply we call it true if we find other compound. And there is some possibility we don't get the match high because we don't deduct the background. Okay, so what else? So for now you can see not many compound detected at 80% and above. Okay, so I think for now we just stop. We will discuss or we will meet again in the next video. Then I will show you other ways of how to get a better matching for each of the pick. Okay, that's all everyone. See you in the next video. It's very long time not posting any video in this channel. Assalamualaikum warahmatullahi wabarakatuh. Hope this helped you in your work, your stuff. Bye.